Hello and welcome to this video that goes through the Edexcel AS Statistics and Maths questions. We're looking at exercise 2D question 1. So for question 1, the lengths of a number of slow worms were measured to the nearest millimetre. The results are shown in the table. The first thing we've got is work out how many slow worms were measured. So for this one, it's very straightforward. All we need to do is we need to just find the cumulative frequency of our table. So we know the frequency for each class, so we just add them up. So you could draw a column here, cumulative frequency, and it's going to be 4, 4 plus 4 is 8, 8 plus 2 is 10, then 10 plus 7 is 17, 17 plus 20 is 37, 37 plus 24 is 61, 61 plus 10 is 71. And so your answer here is 71. The next thing we need to do is estimate the interquartile range for the lengths of the slow worms. So to find the interquartile range is equal to Q3 minus Q1, where Q1 is the 25% value, or a quarter of the total frequency, and Q3 is 75%, or 3/4 of the frequency. Okay, so for here, let's find Q1. So Q1, the first thing we need to do is find what the quarter of the frequency is. So we do 71 over 4. So 71 divided by 4 is 17.75. Remember that this is an estimate. We don't need to do any of the plus ones or anything like that. It is just an estimate at this stage. So we can just directly divide by 4, and if it was an estimate for the median, you would directly divide by 2. So here's 17.75. So there is two methods that we can do to find what our actual length is that we're interested in. So here we're going from the frequency, and we're finding out if the frequency of the 17.75, what does that correspond to, or an estimate of that length. So here, the two methods we have, the first one is the formula method. Actually no, I will show you the formula that we can use, but I will go through it in terms of the ratio. So the formula is equal to the lower class bound plus the width times our value that we're interested in. So in this case, this case will be Q1 minus the cumulative frequency of the previous class divided by the frequency of the class. Okay, so what is the first thing we're going to do is the lower class bound. So here we're looking at 17.75. Now here that means that it's going to be in a particular class. So to find which class it is, we look through the cumulative frequency. We find that 17 is at 170 to 184, so that's the maximum of this class. So therefore the class that we're in is going to be the 185, 199 class. Now notice here that the classes are not, the numbers do not match up in terms of there is a gap between the end of the previous class and the start of the next class. This means that we need to do some bits of rearranging, because for example if you had a length of 184.2, you would have to choose which class you do. Now you would do that through rounding, so obviously you would round that down. So that means that the maximum in this class is 184.5, and then that makes the minimum of the next class to be 184.5, because anything above 184.5 would round to 185. Now what might be a good idea is that you write the class bounds in before you start solving the question, so that you won't make a simple mistake. So you can just simply look at the bounds and then solve, and then plug it in. So 169.5, and then 199.5, 199.5, 214.5, 214.5, and 229.5. So here the lower class bound in our class that we're interested in, so we're interested in the 185 to 199 class, because that's the next one above 17. So it's going to be 184.5. The next thing is to find the width. Now to find the width of the class, you're going to use the upper bound and the lower bound. So it's going to be 199.5 minus 184.5, and that gives a value of 15. Then we plug in Q1, so Q1 here is 17.75, minus the cumulative frequency of the previous class. So we go to the previous class and we look at that, so that's 17, divided by the frequency of the class. So in this case, the class frequency is 20. So we divide it by 20. And from here, we just plug it in into our calculator. So 184.5 plus 15 times 17.75 minus 17 over 20, which is equal to 185.0625. So from here, put that in. So we found Q1. There is another method that we were going to use for Q3. Now again, you can use this method all the way through, or you can just use the following method that we're going to use. So Q3, we're going to use what's called the ratio method. So again, to find Q3, you are going to do 71 times 3 over 4 to find, again, the 75th value. So 3 over 4 times 71 is equal to 53.25. Now, the ratio method, again, you need to, if you're going to use this method, it's a sort of formula. So what we're interested here is on the left-hand side, we're looking at our whatever sort of variable we're measuring. So it's going to be the length, so essentially the class. And then on the right-hand side is equal to our frequency, or our position, essentially. So on the left-hand side, what we do, and on both sides essentially, is going to be the equivalent of Q3 minus our lower class bound. So our value that we're interested in this case Q3, minus our lower class bound, divided by the class width. And on the right-hand side, it's going to be our, by Q3. Q3 is the value that we're interested in, I suppose. So it's not Q3 as in Q3 is going to be the value, so let's say X, where X is the value we're interested in. And on the right hand side is going to be our Q3 that we already know. So Q3, our position, minus the frequency of the lower class, so minus the community frequency of the previous class, divided by the frequency of the class. So it's a very similar idea of what we've done before. From here, we then plug it in. So if we go to X, so we now need to find what is our class bound. So it's at 53.25. So if we look at our cumulative frequency, we've got 37 and 61. So it's greater than 37, but it's not as big as 61. So therefore, it's going to be in this class here, the 200 to 214 class. So our lower class bound for that class is 199.5. So it's going to be X minus 199.5 divided by our class width. So again, our class width is the upper bound, which is 214.5, minus our lower bound, which is 199.5. So 214.5 minus 199.5, and that's equal to Q3, which we know is 53.25, minus the cumulative frequency of the previous class, which is 37, so that was in the one below, divided by the frequency of our class. So in this case, the frequency of this class is 24. Once we have that, we then rearrange, or we can first of all solve our values and rearrange. So X minus 199.5, 214.5 minus 199.5 is 15. So 15 is equal to 53.25 minus 37. So that's 16.25 divided by 24. From here we rearrange to find X. So X is equal to 16.25 times 15 over 24 plus 199.5. So plugging this into our calculator, you should get an answer of 209.65625. So to three significant figures, 3 decimal places, it's 109656. From here, what we need to do, we haven't finished the question. We then need to do the interquartile range is equal to Q3 minus Q1. So that's equal to 209.656 minus 185.063, and that will give you our value. So 209.656 minus 185.063, so that gives you an answer of 24.593, which is 3 significant figures, 24.6, and that gives you your answer to part B. So this is one of the longest type of questions you would get for this type of question, but once you know the method, it's just applying some formulas and then just solving, rearranging and solving. Okay, so that gives you the answer to part B. To part C, we're going to rip this out because we need some different values for part C. Okay, so for part C, we're looking at the mean, so estimating the mean length. So I'm going to keep our class width, but this time I'm interested in another thing, which is the midpoint. We don't know for the mean. If we have a table, usually you would do your x times the frequency, but here we don't have an x, we've got to find our midpoint. So to find our midpoints, the key thing that we do here is, again, we need to use our proper lower class bound and upper class bound. Remember again that they are not the ones that are stated in the question, because they do not match. The highest value here is 139, then we've got 140, so we need to use our we need to write in, preferably, particularly if you're not strong in this topic, write in your class bounds. So it's 139.5 is the highest one. If we look at the first one to find the midpoint, you do 12.5, so you do your lower class bound plus your upper class bound and then divide it by 2. The same idea as you would for finding the midpoint between two coordinates. Plugging this in, we get an answer of 132. If you want to try a few more of these, pause the video now and try and find the midpoints of a couple of them. I'm going to fill it in just to save some time. So we're going to have 132, the next one is 147, the next one is 162, 177, 192, 207, and 222. From here, we then do the following. We do the frequency times the midpoint. So remember, to find the mean is equal to the sum of the frequency times the midpoint divided by the sum of the frequency. So the frequency times the midpoint is simply just going to be the following. So 132 times 4, which is 528. Then 147 times 4, which is 588. Then 162 times 2, which is 324. When we've got 177 times 7, which is 1239. And 192 times 20, which is 3840. 207 times 24, which is equal to 4968. And 222 times 10, which is 2220. Then all we need to do is sum all of these up. If we sum all of these up, you should get a value of 13,707. We also need to sum up the frequencies. So the frequencies here is 71. And then from here, all we do is we divide them. So it's 13707 divided by 71, which gives us an answer of 193.056, which to 3 significant figures is 193 millimeters. Okay, so the last part we have is estimate the number of slow worms whose length is more than 1 interquartile range above the mean. So for this one, for part D, first things first, we do, as the question says, we do the mean plus the interquartile range. So from this one, it's going to be 193 plus an interquartile range, which is 24.6. Here I'm actually going to use, because I've got a decimal here, I'm actually just going to take the decimal version, 193.1. In the question, usually it will give you a much clearer indication of what you're supposed to use. There is nothing wrong with using the previous answer and getting a very exact answer. That probably would be the best method. And then simplify. Always do your significant figure simplifying, decimal place simplifying as the last step. Keep as many significant figures, decimal places as you can. That's reasonable. So if we add these together, we get 217.7. From here, we're trying to find, well, how many more worms will go through. So here, first of all, let's determine the class interval that this belongs to. So again, we're going to do in a form of interpolation. So we're in the 215 to 229 class. From here, we're going to then use interpolation, but this time we're going to do it on the opposite side. So again, when we do our method, we'll do the ratio method. So the first thing we're going to do is on the left-hand side is our class. So we know already our position that we're interested in this time. We know it's 217.7, and we know that the lower class bound is 214.5, and we know that the class width is 229.5 minus 214.5. Here we're interested in the frequency, so we're going to say the frequency x minus our position here. So here the cumulative frequency up until that point is 61, divided by 71 minus 61. So from here we're going to find the value of x. So we just plug in the numbers. So it's going to be 217.7 minus 214.5. So that gives you 3.2, divided by 229.5 minus 214.5, which is 15. And that's equal to x minus 61 over 10. And then from here we just rearrange. So 3.2 over 15 times 10 plus 61 is equal to x. And this gives you your value. So 3.2 divided by 15 times 10 plus 61 gives an answer of x is equal to 61.13. Okay, so from here we know that up until the values 61.13 of our values do not equal, 63, my mistake, so it's 63. So x equals 63.13. We know that at this point here, that 63.13 values are up until, so mean q plus IQR, this value here is 63.1. We know that the total frequency is equal to 71. So we're interested in how many of those worms are above this one. So essentially, we want to find the difference between them. So it's 71 minus 63.13, which is equal to 7.87, which we can roughly round to 8. Again, it's just an estimate. And therefore, we have 8 worms that are more than one interquartile range above the mean, or an estimate of them. And that's it for question 1. Any comments, please let me know.